What's going on everyone, you're back with your boy Jono for another quick math lesson. Today we're going to have a look at perpendicular lines. How does the gradient impact whether or not something is perpendicular? So perpendicular means right angles. When these two lines cross, four right angles are going to be made. It's kind of like a perfect X, right? A perfect cross between two lines. If we have an X that doesn't look exactly perfect, these two lines are not perpendicular. What we know for sure with these perpendicular lines is that one of them is going to be positive and one of them has to be negative. If we go back up to our perfect X, if I played around with this and tried to make both of the lines have a positive gradient, so I've deleted one of them, this one's going uphill. If my other line's going uphill as well, there's no way that I can make it a perfect X. These ones all have really small angles and really big angles. If we go down to a graph and have a look at this black line, this has a positive gradient as well, and my perfect X is going to be going downhill. Again, if I tried to make it so that I had two positive gradients, I can see that two of my angles are going to be way smaller than 90 degrees, and the other two are going to be way bigger. So the first thing that I've got to take away is that a positive gradient, the perpendicular line for that one, is going to be negative. And the same thing happens the other way. A negative gradient line, its perpendicular line is going to have to go positive. The other thing that kind of complements this as well is that if we've got a really steep line, to make the perfect X, I need to have a really flat line. And we're going to see a couple of examples of that just now. So if I go into this graph, I've got that the gradient is positive 10, so straight up, pretty steep for this graph. If I have the exact mirror image of this, so down 10, m is equal to negative 10, I can see that there is no way that this is a perfect X. None of these angles are going to be 90 degrees. The two angles, the vertical ones, are way too small, and the two horizontal ones are way too big. So the only way that this could be more perpendicular, the way to make a perfect X, is instead of having a really steep downhill line, I could flatten that out to something like this. This looks way closer. All of those angles are much closer to 90 degrees. So I've got my positive steep line, and now I've got my negative flat line. So positive, negative, those two things are important on both sides of the coin, and then steep and flat are going to go together. So we're really just talking about complements. What complements the other line? So the technical definition for a perpendicular line is that its gradient is going to be the negative reciprocal of the original gradient. We already saw the negative thing, right? A positive line has to have a negative one cutting through it, and vice versa. A negative line has to have a positive one. So that just means opposite. Reciprocal is what we're talking about with the steepness. A steep line has to have a flat buddy, and a flat buddy has to have a steep one. So these two ideas, even though they sound a little bit harder, we've already talked about. Negative and reciprocal. So the way to find this is just we have to change the sign of the original gradient and then flip the fraction. This is actually what a reciprocal is. So if I had 3, I've just got to turn that into 1 over 3. The reason for this is 3 is the same as 3 over 1. If I flip that fraction, I've got 1 over 3. And because it's got to be negative, I'm going to whack a negative out the front. So a question could look like this. Y is equal to 2x. What line would be perpendicular to it? Because I'm looking for the negative reciprocal, all I'd have to write is y is equal to negative 1 over 2. That's the 2 over 1 flipped around, and I've made it negative. For these questions, the y-intercept actually doesn't matter. It could be anywhere on this line and still be perpendicular. I've just left it as 0, so these two are passing through the origin. Now if I have a look at this on the graph, if I've got y is equal to 2x, that's that positive line going up. So it's kind of steep, so I know that my negative line is going to have to be flatter than that, and I have found that. I know that it's negative 1 down across 2, and these two cross at a perfect X. Each angle that's made at the crossing point is 90 degrees, so I know I got this right. This next question, I'm trying to find the perpendicular line to negative 3 over 2x. Because it's negative, I've got to switch that, so the perpendicular line is going to be positive, and I've got to flip the fraction. Instead of 3 over 2, it's 2 over 3. So my answer is just y is equal to 2 over 3x, and we're done. So it's pretty easy to find these perpendicular lines if you've got the original gradient. Hey, flip it, make it negative. The other rule about perpendicular lines, if you multiply the two gradients together, it has to equal -1. And we can see this in an example incredibly easy. If I've got 3 over 1, which is just 3, multiplied by its negative reciprocal, or negative a third, -1 over 3, if I multiply these two together, multiply the top makes -3, multiply the bottom makes 3, Negative 3 divided by 3 is just negative 1. So these two things that I know for sure are reciprocal, when we times them together, it's going to equal negative 1 every single time. So are these two lines perpendicular? I've got y is equal to 4x and y is equal to negative a quarter x. All I've got to do is 4 times negative a quarter. 4 times negative 1 is negative 4, and then 1 times 4 is equal to 4. Negative 4 divided by 4 is equal to negative 1. So these two lines must be perpendicular. So that question was obviously pretty easy. It's just a negative and a flip, but this is really helpful when we don't have a fully simplified fraction. And that's where this can really help out. Because again, when we multiply them together, it has to give negative 1 as the answer. So we want to know if negative 10 over 6x is perpendicular to 3 over 5x. So for this, I just have to multiply them together and hope that the answer is negative 1. Negative 10 times 3 is negative 30 up the top, and then 6 times 5 is 30 at the bottom. Negative 30 divided by 30 is equal to negative 1, so these two things are perpendicular. So the only thing we really need to know for this lesson is that to find a perpendicular line, we just have to look for the negative reciprocal. And all that means is we've got to flip the fraction and change the sign. Thanks so much for watching this lesson, and I'll see you later.